Okay, we'd just like to mention a handful of properties that are true for double integrals. A lot of these properties have complete analogies back in earlier calculus classes. So if you have the double integral of f over d, but you can split up d into two separate kind of disjoint pieces that only meet along, like a boundary fence like this, then you could write this as the sum of two separate integrals. This is really analogous to when you integrate in Calc 1, like integrate from a to c. That's the same as integrating from a to b, where you stop in the middle. B is, and then you integrate from b to c, right? So just think about what's going on here, really, right? It's like the area under the curve from x equals a to x equals b, and then this is the area under the curve from x is b to x is c. So if you just don't stop at b and you just do it all at once as one area, that's the area under the curve from a to c. So that's the same thing, same idea that's going on right up here. Also, there's the property that if you integrate the constant function 1 over a region D, you actually just get the area of D. This is actually analogous to the following. We don't really probably think of it this way, but if you were to integrate the function 1 with respect to x from x is a to x is b, you end up getting b minus a. And b minus a, think about it, happens to be the length of the interval from a to b. So that length of interval, the region you're integrating over, is analogous to the area of D, the region that you're integrating over. Here's another property that sometimes makes some use in Calc 1, Calc 2, and is that if you know that the values of your function are between little m and capital M, at least for all inputs that are in the region D that you're about to integrate over, then you can create a quick estimate of what that integral is. So if you don't want to compute it directly, but you just need to know what's it smaller than, what's it bigger than. You know that it's going to be squeezed between little m times the area of the region you're integrating over and capital M times the area of the region that you're integrating over.